Okay, this is lesson 94, number 24. It wants to find the distance from this point to the line 3x plus 4y equals 2. Okay, so I need to find the distance. I want to use the distance formula. I have this point, but I don't have another point. So I am going to graph it just so I can keep track of the concept of what I'm doing. So here's my point. It's -1 and +2. So there's my point. And then this line, well, I'll probably put it in y equals mx plus b. So I can say 4y equals -3x plus 2 divided by 4. So that gives me y equals -3/4 x plus a half. So now they're just being mean. No, they're not being mean. No, they started out giving us, I think in the beginning they gave us nicer numbers. Now we get a lot of fractions because that's how it is in life. Stuff's messy. So here's the, I'll make this in red, although I know you can't see it on the screen as red. That's the intercept, and then it goes down 3/4. So let's make these in, so if I go down 3 and I'm at a half, that's kind of weird. It's going to be like 1, 2, 3, and then over somewhere like that. So then it looks like it's running right into my line. It looks like it's touching it, right? So it's some minute little small area. So drawing the picture, maybe they're trying to dissuade me from drawing pictures from now on. So I can find the distance by finding a line perpendicular to the line, to this line, y equals -3/4 x plus a half. Did I do that right? I subtracted 3 divided by 4. Okay, so the slope of this red line, if you can see the difference of the colors. Yeah, I want the negative reciprocal, so it's going to be +4/3. So I'm going to have y equals 4/3 x plus b. And then I'll just use an x and y that's going to be on my line. My line's going to go through -1, 2, so it's going to be 2 equals 4/3 times, -1 plus b. So that's going to give me -4/3, that right there. And then that's, I'm going to want to add 4/3 to both sides. Yes, I have 2 4/3, which is like 3 1/3. And that's b. So 3 1/3, 3 times 3 is 9, that's 10/3. I just probably want it like, I like it like that, 10/3. And that looks like, I mean, when I look at my little graph, it looks like it could be sort of accurate, so that makes me feel like I didn't do anything horribly wrong with my algebra. Okay, so now I have an equation of a line. Y equals 4/3 x plus 10/3. So here's the blue line's equation, and this one over here is the red line's equation. And so what I want to do is I need another ordered pair. I know it's hard to tell between this black one and this point of intersection, but I need to know that point of intersection, so that's why I'm going to do the system of equations on the two lines. So I like to use, we call it equal values method, or you can just call it substitution. Since this y is equal to that, I can kind of set this thing equal to this thing and pretty much set them equal to each other. So I'll go -3/4 x plus 1/2 is equal to, it's like fraction math city right here, 10/3. I can clear the fractions if I want to, or I can not clear them. If I multiplied by 12, I could clear them out. That'd be a relief for me. So I'm going to multiply everything by 12, like 12, 12, 12. Every single thing is going to get multiplied by 12. I can do it kind of in my head. This 4 is going to cancel out, and this will be a 3 times 3, that's -9. And then 12 times a half would be 6. And then that would be 16. Yeah, and that'd be 40. So that's pretty easy. And then I can, I'm going to add 9. What's 16 plus 9? Is it 25? Okay. And then I'm going to subtract 40, and so does that give me negative 36, or?
34.
Oh, 34, thank you. Yeah, so negative 34 over 25, so that's what x equals. Negative 34 over 25, and then we can find y, we can plug in y somewhere. So that's ugly wherever you put it, so I used to just put it, maybe put it right here or something. So 4/3 4/3 times negative 34 over 25 plus 10/3. I'm going to talk to my calculator, and then I'll get back to you people. 4/3 time. Oh, my calculator doesn't want to talk to me. 4/3 times negative 34. I'm cheating and using my calculator. Over 25. That's that. Plus, because I didn't want to deal with all the common denominators. Plus, I got 38/25.
That's what I got.
Oh, good. Yeah, after a while I just didn't want to play the fraction. That's why. I didn't want to play the fraction math game anymore. So now I have an x, I have a y, and so that's an ordered pair. So now we'll go down here on some clean paper and get my two ordered pairs. My first ordered pair was just the original point, negative 1, 2. My other ordered pair was negative 34/25, 38/25. And before I put those in the distance formula, I'm going to check them with, just check with my answer book so I don't waste a whole bunch of our time. Now they're right so far. So it really, really wants us to, they really want us to put those in the distance formula. So distance formula, you can stick the, let's see, doesn't it have like the x2 minus x1, y2 minus y1? So here's an x and a y. So and then something like that, and then we have this mess, and I'm going to put it in the calculator problem. Oh no, I can do it. That would be 25/25. 25, so 34 minus 25. So that's going to be 9. $38 minus 50. 38 minus 50. Negative 12. So there's all this ugly math happening, and then we end up with, hey, isn't that cute? So cute, look. Turned out to be nice, right? Because that made the 81 over 625, and that made 144, and then they added in there. They're both perfect squares, because isn't that, that's like 15 over 25, I think. Like, yeah, that's 15.
And we can just reduce that afterwards.
Yeah, 15 over 25. And then, so if I do that by 5, so I'll get 3/5. Okay, so I forgive the book now, because that was actually really cute at the end. What does that stand for? Did we answer the question? That is the actual distance. So no wonder, look how small that distance looks. No wonder it's only such a tiny fraction, right? I mean, if you look at